Okay, chapter 12.3 is we're approximating square roots. And approximating is getting close to a square root when it's not one of those perfect squares. First, maybe we need to look at some numbers. We've got real numbers. Real numbers include everything except for imaginary numbers. And we're not going to talk about imaginary numbers until you're in high school. But real numbers include all of these over here, which are rational numbers. And you can take rational numbers in one group and irrational numbers in another group. And inside of rational numbers are integers, whole numbers, and then natural numbers. And this doesn't list natural numbers, but we could make another circle. Natural numbers and whole numbers are almost the same thing. Natural numbers are just counting numbers. And they include 1, 2, 3, and so on. Whole numbers simply add a 0. They're the same numbers, but they add a 0. Natural numbers don't really include a 0 because they're not natural. You don't think of nothing as being a number. But when we get into math, it becomes a number, and it's a very important number. 0 is a hugely important number. And so we have whole numbers that include all the regular numbers plus 0. And then we have integers. And integers include all of these numbers too. See how whole numbers are inside integers? And whole numbers and natural numbers are all inside integers, and integers include all the naturals, all the wholes, but also include negative numbers. So we would have like -3, -2, -1, 0, 1, 2, and 3. Okay, and so this is almost like a number line where it goes forever in -4, -5, -6. It goes forever in that direction. It goes forever in that direction. Integers are all of these numbers, and all all of these are rational numbers, and all of these over here are irrational. And irrational numbers are kind of irrational. They don't make sense a lot. An irrational number cannot be written as a ratio of two integers. So like even weird numbers like 1/3, which is 0.33333, and it goes on forever and ever and ever. That goes on forever and ever, but it can be written as a fraction. So it's a rational number. It's some of these other numbers that cannot be, that are irrational. Pi is irrational because it's 3.14159, and it goes on forever, and there doesn't appear to be a pattern. It cannot be written as a ratio of two integers. It's close to 22/7. That's a fraction. That's a ratio of two numbers. 22/7 is a close approximation of pi, but it is not exact. So pi cannot, or we have not figured out a way to write it as a ratio of two integers. So it is irrational. All the irrational numbers are over here. And any square that is not a perfect square. The square root of 2 is irrational. The square root of 4 is not, because square root of 4 is equal to 2, so square root of 4 would be a rational number. The square root of 3 would be irrational. Negative square root of 3 would also be irrational. -2 times pi would be irrational. Anything times pi really would become irrational. And so those are things that you just need to remember. A decimal form of an irrational number doesn't terminate and it doesn't repeat. So sometimes you get a decimal like 0.1313, but if it goes like that and becomes 5, 7, 9, 1, and you never do get a repetition, the pattern doesn't repeat, it's an irrational number. Okay, so that just gives us a chance, and you've got to be able to identify irrational numbers as you're looking at your book, and page 526 will help you if you don't have my video right in front of you. Okay, so when we're approximating square roots, this is like estimating. So we're going to estimate the square root of like 52, and we have to figure it to the nearest integer. So to the nearest integer is pretty easy to do because that's a whole number. And if we think about a number line going on with numbers, And we don't really know what the square root of 52 is. We could put it in a calculator. But what we could do is we could think of some of those perfect squares that are nearby. The square root of 49 is equal to 7, because 7 times 7 is 49. Well, what's 8 times 8? Well, it's 64. That means the square root of 64 is 8. So if we were on a number line where we had 6, 7, 8, 9, 10, and it was traveling in both directions forever, the square root of 52 is going to be somewhere between 7 and 8. And we could actually kind of figure out that, because if we were just counting 49, 50, 51, 52, 53, be patient with me. This is going to take me a little while. 67, I wanted 57, 57, 58, I don't know what that was, 59, 60, 61, 62, 63, 64. Okay, so 49 is square root of 49 is 7. 64, square root of 64 is 8. We can see that the square root of 52 is actually pretty close to 49, and it's far away from 64. So if 49 is 7 and 64 is 8, then 52 is actually going to be closer to 7 than it is to 8. That's really as close as we really need to get. Square root of 52. So that's actually not very complicated if you know all your perfect squares. If you know what 9 times 9 is, and 10 times 10, and 8 times 8, and 12 times 12, etc., you could figure these out really well. So that should be pretty easy. Which is greater? Which is greater, square root of 5 or 2 3/4? Okay, so which is greater? Okay, this is a great question. We could figure out some things again by using a number line. We know that the square root of 4 is equal to 2. And we know that the square root of 9 is equal to 3. So if we had 2 here and 3 here, we could decide the square root of 5 is very close here to 2. Square root of 3 is all the way up here at 9. So what is 2 3/4? 2 3/4 is the same as 2, not 3, 2.75. Hopefully you remember how to convert your fraction into a decimal, especially the fourths. And the square root of 5, we're kind of having a guess. But I would guess that 5, square root of 5, it would be bigger than 2, smaller than 3. Where does it compare to 2 3/4? Well, let's see, we have 4, 5, 6, 7, 8, 9. And to get from 4 to 9, and 5 is right here. So we would think that square root of 5 is close to 2. And 2.75 is close to 3. And that gives us a little piece of logic to fall back on. So this would be 2.75, and this would be square root of 5. So we could see that 2.75 is greater by using some logic in our number line. We can do that one more time with 0.06, bar over it. So that's 66666 goes on forever, or square root of 0.36. Okay. Now we can do this one. Let's see if we change this. The square root of 36 is equal to 0.6. And we can extrapolate that because 6 times 6 is 36. And so 0.6 times 0.6 would be equal to 36 when we count our 2 decimal places. So we'd have to put it there, 0.36. So this one we can actually do in our head. We can use a calculator. So which is bigger? Well, on a number line, 0.6 and 0.7. Oh, I wrote this one wrong. Okay. Oh, because this has a bar and this is equal to 0.6. This goes on and on, so this one is actually going to be bigger. It's going to be close to 7, so it's going to be up here, 0.6 with a bar over it, and this one is exactly 0.6. So the square root of 0.36 is right here. Okay, that was a little bit confusing because I wrote that down wrong right there. Let's rewind that and watch it again just so that we make sure we get that. Otherwise, you could be slightly confused. Hope not.